So there are all the right answers. I can explain them out if anybody wishes me to, unless you were not here. If you were not here Friday, don't ask me to explain it now, because if you watch Friday's video, it explains how to do this all. So if you were actually here Friday but still don't have one of these answers, then ask me now. Everyone okay? Yeah? Okay. 31. Change to an entire radical. Cube root 108. Fourth root 6,480. Just like he said. Cube root 700, 875. Change to a mixed radical. Square root 105. Doesn't change. You cannot do that because it's 5 times 21, which is 5 times 3 times 7. No pairs. So it's already done. This one is 14 because that is 14 times 14. You take out the pair. C is 6 cube root 2. D is 5 fourth root 6. Everybody okay? E is 8 root 6. And F is negative 12 root 5. Everybody good? Yes? Yes? Okay. Now, at the bottom here, I wanted to show you one more thing. And then I am going to shut up and let you work on number 7 and 8. Okay? But I want to show you one more thing before I go any further. 2 more things, actually. The 2 things I'm about to show you are not new. They're just extensions of what you already know. Okay? The first one is this. 1/2 root 32. If I asked you to simplify that, what would you do? Again, you already know how to do it. So what do you think you would do with that? You've got a couple of options here. What? Shaq? You do the same thing as before. So you'd simplify this, right? And that would be 16 times 2, yeah? And what's the square root of 16? 4. So a 4 would come out. 4. You already had a half out there, and you left 2 under there. What do you do with those 2 things? Multiply them, because they're all coefficients, yeah? What's 4 times a half? 2. So you would get 2 root 2. Is everybody cool with that? That's one thing you could do. The other thing you could do with this is this. It's root 32 over 2. Right? Then you would simplify there to get 4 root 2 over 2. And then 4 and 2's, 4 divided by 2 is 2 root 2. Is everybody cool with that? The fraction in front is just a coefficient. Nothing else changes. You just multiply all your coefficients together. Is everybody all right with that? Yeah? Okay. That's one thing I wanted to show you. The next thing I want to show you is this. What is the square root of 9? 3. Everyone agree? Why? Because it's 3 times 3. Cool? All right. Now, what is the square root of x squared? X. Why? Because it's x times x, and you take out the pair, right? So what then is the square root of x cubed? X root x. Cool? because this is XXX, naughty, and I take out a pair, right? Everybody okay? So what then is the square root of x to the fourth? X squared, because it's x, 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 x. I take out two pairs and I get x squared, yes? Everybody still good? Okay, so now what is the square root of 9 x to the fourth y to the third? Again, this is nothing new. This is everything you already know put together in one question. Three x squared y root y. Is everybody cool? Because this is really saying the square root of 9 times the square root of x to the fourth times the square root of y to the third. Now, all of you should have noticed the shortcut too, right? If I wanted square roots, x to the fourth square root, it's just divided by 2. Y to the third square root divided by 2, and I leave the remainder in there. Everybody got it? Everybody cool? Yeah? Okay. I'm going to assign you page 32, but not right now. Okay? I want to do a lesson today, and then I'll add 32 on to the next thing you do. All right? Okay. So if everybody would be so kind as to turn your page over to page 33, which is adding and subtracting radicals. And again, you did a bit of this last year. Some of you maybe didn't do any of it last year. I hope that you all did. If you were in my class, you did. But again, you already technically know how to do it. What I'm about to write is something you know from the 9th grade. Please do it. What is x plus x? What does that equal? 2x. Why? Don't ask me why. Why? Because there's two of them, right? I know you hate them, but if you go back and think about algebra tiles, there's two x's, right? That's why it works. Cool? Okay. So what is 3x plus 2x? 5x. Lovely. Why? Because there's 3 of them and then there's 2 of them. Everyone's good, yes? What is 4x minus 2x? 2x. Lovely. Well, you can do this all in your head, yes? What is it about this whole section that allows us to do this in our head? Because until you saw algebra tiles, which we never got to use when we were kids, think back 20 years to why am I able to do this without using algebra tiles? What is it about this line that allows me to make those assumptions? The coefficients and, pardon? Simple addition and subtraction. Okay, so that means, what is this? Y. Because it's x's and y's. This is not like terms. So we can't add it together, yes? Everyone agrees? Because this is a coefficient. Correct? Now, if this and this are the same, if they're the same, we can work with the coefficients, right? But they have to be the same. Cool? Because all this is saying is x is an unknown number. Yes? And here x is the same unknown number. Right? So I can put them together to get 5 of that same unknown number. Is that cool? So if I give you something like this, 3 root 5, what does that mean in math class? What is actually happening there? Right, this is 3 times the square root of 5, correct? And what is 3x, technically? 3 times x. So because these are the exact same thing, we use the same rules for radicals as we use for variables. So 3 root 5 plus 8 root 5 is 11 root 5s. Cool? Because root 5 and root 5 are the same thing. We don't know what it is, but we know that if I take 3 times that and I add 8 times that, I'm going to get 11 times that. Right? So that is why this root 3 doesn't work. Because when I do 3 times root 5, I'm not going to get the same thing as 8 times root 3. Everybody with me? So the first point of this is, unlike radicands, cannot add or subtract. They can't. They have to be the same because they're an irrational number and they are not the same thing and they go on forever. Everybody cool? All right. So let's look at this very first one here. What are we going to do with that? I'm going to add up which ones, Michaela? Yeah, all the 7s. Now, does the radicand change? No. Just like 5x and 3x gets me 8x, only the coefficients change. So I got 5 minus 3 minus 4. What is that? So I have negative 2 root 7 plus root 2. And can I go any further? No, I can't. Everybody cool? It's pretty easy, right? All right. Look at the next one. Can I do that right now? Why not, Michaela? The radicands aren't the same. But is there some math I can do to those radicands? Yes, I can simplify them, right? Because this is 16 times 2, and this is 4 times 2. What's the square root of 16? So it's 4 root 2 plus 2 root 2, which is what? 6 root 2. So this is the first warning. Simplify whenever you can. Okay, always simplify. There's a reason for doing it. So looking at this next one, we can't do anything with it on first inspection, right? Except we can do something with it because we can simplify. What does the first one become? Seven and 4. Does one of those have a square root? What? 2. So out comes a 2. There's already a 5 out there, so what do I have? 10 root 7. What's 63? 7 and 9. 9 has a square root. Out comes the square root of 9, which is 3. There's already a 3 there, so what do I have? 9 root 7. And 112? 16 and 7. What's the square root of 16? 4. There's already 2 there, so plus 8 root 7. Then I can just add it up. And what's the answer? 9 root 7. So please understand, nothing new is happening here, but you are just being asked to do everything you have ever done with radicals and polynomials. Understand? We could have shown you this in the 3rd unit of the 9th grade. But for some reason in BC, we don't like to do that. We like to get you up to a spot and then never talk about it again until 2 years later, instead of finishing one concept all the way through. So what am I going to do with D? Same thing. What is 20? 5 times 4, so it's 2 root 5. What's 45? 9 times 5, so it's minus what? Minus 9 root 5. So what does that give me for an answer? Negative 7 root 5. Nothing changes. The rules stay the same. Is everybody cool? Yeah? Okay, you guys do 2A and B. It's the same rules, they're just a little longer. Stop after B, though. Thank you. So is everybody okay with A and B? You don't have to be done. It's not a race. I have practiced a little bit more than you. Sydney. 47 root 7. Oh. 47 root 2. Thank you. Minus root 7. But again, it allows me to say, what if you had done that? What if you had written that on your test? Well, you've done everything right. You've just, what am I going to do? I'm obviously not going to punish you for that because it's not a concept you're missing, right? You wrote both root 2's right there. You knew it was root 2. Picking up what I'm putting down? Now, we get into some gray areas there, don't we? Right? And sometimes I make a judgment call on what you were doing, right? For example, 3 to the negative 3 is never negative 27. I used that one because quite a few of you on your test told me that 3 to the negative 3 is negative 27. All right, so everyone's cool with these? There's nothing new there, right? Okay, so what's different in C? Do you think? They're cube roots, but do you think anything else changes? Of course not. if I change 5x plus 3x to 5q plus 3q, we do the same thing, don't we? So here we do the same thing as well. They have to be the same. Now the only thing that's added to this is, could I add a square root plus a cube root? The radicands are the same, but can I put them together in adding? No. Okay, so this one, they're all cubes. So right now, all their indices match, but their radicands don't. So our first step is always simplify, right? So now we got to look for cubes, yeah? So that's 27 times 4, 8 times 4, and having trouble with that one. 64 times 4, thank you. So that's going to be, what comes out? 9. What comes out there? 2. What comes out there? 4. So I end up with 27 cube root 4 minus 4 cube root 4 plus 12 cube root 4. And I put it all together and get 35 cube root 4. Yes, now.
For the say the first one, you got 9 out of 27. Where did you get 3 because you need to do that?
Oh, yeah, should have been a 3. Thank you. That should have been 9. Thank you. So 9 minus 4 is 5 plus 12 is 17. Sorry about that. My head is full of snot. Everybody good? Now, most of you should be picking up the pattern that really the only thing that's happening to you in the 11th grade is we're asking you to remember everything you've been taught in math from grade 2, right? That's why grade 11's hard. It's the first time that we have said, okay, you remember that thing that we taught you in the 4th grade that you really haven't done since then? Now you need to know how to do it again. Everywhere else in the world, they keep doing it all the way along. That's why some kid from Singapore did this in the 3rd grade. Okay? So let's look at the next question. Because right now it looks very frightening, doesn't it? Right? But it isn't, because you know what to do with this. Right? This is what we just talked about today. How can I make that prettier? What would you do with that?
Divide the 9 and 48 by 2.
You can't do that because the 48's in a radical. But it's a good idea. You are going to do some simplifying of fractions because that's a fraction, isn't it? And you know how to deal with fractions. But before it's a fraction, it's got this radical in it, doesn't it? So what would you do to simplify that radical? As you practice more, you're going to start seeing 16 and 3. That's the perfect square, yes? What's the square root of 16? 4, right? So a 4 comes out, and what stayed under there? Oh, wait, we don't want square root, dummy head. It's cube root, yeah? So it's 8 times 6. What's the cube root of 8? 2. So what comes out? 2. So I'm going to have 2 times 9, cube root 6 over 2, correct? What's 2 times 9? 18. 18 cube root 6 over 2. Now what? Now, of course you cut away the 2. Exactly. You could have done that before. But if I just write that nav, somebody says, where'd that 2 go? Right? So, what do I do with 18 and 2 now, as Nav has just pointed out? If there was no cube root 6 there, what would you do with 18 and 2? Divide them to get 9, right? So what's this? 9 cube root 6. Cool? Okay. What are we going to do with the middle one? Barf. What is that? How can I make that prettier for me to work with? There's a lot of options there, isn't there? Right? Can I simplify 162 and put a coefficient out in front? And then multiply that by 3/4. Is that okay? Some of you are not comfortable with that. That's fine. Could I also do this? So choice 1 is simplify and move out a coefficient. What about this? 3 cube root 162 over 4. Is that okay? Then it's the same thing, isn't it? Simplify the 162, bring out a coefficient, divide by 4. Is there a right or a wrong way to do it? No. There is a right or wrong answer, but there's more than one way to do it, right? You'll notice in this one, I chose to go the second route, right? So is it all right with everyone if I do this one the other way? You can do whatever you want, but I'm going to go the other way. I'm going to bring out an exponent or a coefficient and multiply it by 3/4. Is that okay? I don't care what you do. I'm going to do that way. So this becomes for me 3/4 cube root of 162, which is 27? No. 27 times 6, yeah? 27 times 6. I'm going to bring out the cube root of 27, which is 3. And I'm going to get 9/4 cube root 6. Yes? So, hey, cube root 6, cube root 6. Are they like terms? So far, I have 9 plus 9/4 cube root 6. Everyone cool? Okay, and what's the third one? 3 cube root 750 over 5. Do I do anything different? No. What's the cube root that I'm looking for in 750? 125 times what? 6. So this is 125 times 6. Now I notice some of you are, what's the word I'm looking for? You seem, you are impressed by some of your peers' ability to do this. Right? That's not, and I'm not putting down them. That's just practice. Right? Like, I just think, I see it's a cube root, so I'm thinking of cube roots that work there. And it's only that I've practiced it more that it's stuck in my head. Speed is not necessarily a guarantor of correctness. As you guys have seen with me, sometimes I'll do a whole bunch of work super fast and somebody will say, idiot. Well, you won't say that. You're nice to me. Mr. Myers. But in your head, idiot, right? Speed is good, but by all means check, right? It's like some people are really quickly able to factor a trinomial while some people have to think about it, right? It's no big deal that some of your peers are really good at this. But if you are really good at this, don't feel that I am trying to lower your achievements. Understand? So what's the cube root of 125? 5. So I end up, out comes a 5. So I've got 15 cube root 6 over 5. What are you going to do with the 15 and 5? Divide it to get what? 3 cube root 6. So what do I have to do to this section here now? I got to bring a 3 over here, right? Because I got another root 6. So now I have 9 plus 3 plus 9/4 cube root 6. Everybody cool? Now, yes.
Oh, never mind. It's 41.
Cool?
Just add it.
Yeah.
Okay.
Everybody good with that? Now.
Yeah.
Oh, is it minus 3? Oh, yeah, okay, thank you. 9 minus 3. Everybody good? So what have I got there? 6 plus 9/4, which is 6 plus 2 1/4, yes? Which is 8 1/4 cube root 6. Is everyone cool with that? Now, how many different ways could I write that? There's a ton, right? This is the same as 33 over 4 cube root 6, isn't it? And it's 33 cube root 6 all over 4, isn't it? Do I care what you do? Not even a little. Understand? And here is what I mean by that. The work we did was pretty, everyone's cool with it, right? It's just simplify and do fractions, yeah? Everyone agree? Could I not, and you don't have to write this down, could I not have done this? And please don't write this down because it really confuses the issue. Could I not have done this? 9 cube root 48 over 2 plus 3 cube root 162 over 4 plus 3 cube root 750 over 5. If I'm going to add those up, don't I need a common denominator? Which is 20. So 90 cube root 48 plus 15 cube root 162 plus 12 cube root 750. Are we still okay? Everything over 20? Then simplify, then add. Oh, it was minus. Then simplify, then add, and then divide by 20. Would I still get the right answer? Yes. But that, Sydney's already like, I would never do it that way. But it's okay, isn't it? Because you're just adding fractions. Does everybody understand? I can't go in your head and know which way works for you. I can only show you a couple of ways and then you have to decide. Sometimes you'll mix the two. Does everyone get that? The point I'm trying to make here is this functions just like a fraction. However you would deal with a fraction, you can deal with this that way. Don't be put off by the Radicands. Cool? That's the point I'm trying to make. Everybody understand? I personally think the way my brain works, the way I did this from when I was in grade 11, this is what I would have done. Because my grade 11 teacher this is how he taught us. He didn't say, well, you could do it this way, you could do it this way, you could do it this way, you could do it this way. Right? Whereas I am thinking for you guys, and that first way we did it, breaking it down chunk by chunk, I find that easier to teach to you guys. Because you guys have been very clear to me that you don't like dealing with fractions. Whereas I'm very comfortable with fractions, so I have no problem doing this. Okay? I don't care. Break it down, do this, it doesn't matter. Do what works for you. This is your math class, not mine. I'm only trying to guide you through it. Got it? Do what works for you. And the other side of that coin, if you find a way that works for you that isn't one of the ways I show you, do it anyway. Because when I mark your work, if I like it, I'm just going to steal it and teach it next year anyway. I'm going to say, hey, I used to teach this kid that did this with these questions. I don't know if it always works, but it always worked for them, so I'm going to show you that too. They said that was easier. Understand? Everybody cool? All right. So you guys did those two on your own. Good. Let us move on. Okay. Go. You guys should have no problem with that. Do 3 A, B, C. Actually, I think I can just stop today because that's a really tough question, that last one I gave you. I am going to stop today. You guys go until 37. Don't do 37. That's multiplying radicals. Work on everything up to and including page 36. Okay? Huh? And 32. Yeah, that page that we skipped. Okay? One sec. So that was, what was that? 32 and 33 to 36? Was that it? Page 32 and 35 to 36? Okay, that's your work for today. Guys, I'd like to do a quiz on radicals. You are going to do multiplying radicals, dividing radicals, and we've already done adding and subtracting. I'm going to warn you, dividing radicals is tricky. It's very tricky, and it's got a weird step in it that doesn't make a lot of sense. But multiplying radicals is easy. I want to give you a quiz after multiplying. Is that okay? All right, we're going to do multiplying tomorrow. You'll do work on it Thursday-ish. So you're looking at a quiz on adding and multiplying on Friday. Okay? Everybody good? If you missed your test on Friday and you don't have anywhere else to go for X block, please put your name on the board in block A and come here for X block on Friday. You won't need the whole hour, I don't think. I seem to remember we all got done pretty quickly on Friday, yeah? Nobody took the whole 80 minutes, did they? I think you'll be okay. So please sign up. Unless, of course, you have another class that you also miss a test in, and that teacher is not as easygoing and cool and good-looking as me. So basically nobody, right? Although I will admit I am not the 100% good-looking that I usually am. I got a little zit. I'm really down about it. I'm 42, and I got a pimple. My son was sitting at the computer, and he scratched his ear and went, "Ow! Dad, can you get zits in your ear?" And I was like, "Well, there's skin in your ear, maybe. Come let me look." And he's got one little tiny zit in his ear. It's those little tiny ones that hurt so much. The little ones, he's got one of them in his ear, and he can't get it. And he's like, "You got to pop it for me, Dad." It's like, "No way, that's not my business. Go see Mom." Because as you all know, gentlemen, girls love popping zits. It's true. See? They love it. I've told the story about a female doctor that tried to make my eye burst out of my head. I'll tell you that story if you care to hear it, Jordan.
Sure. You're still recording that, right?
Yeah. I used to have a female doctor. And the way I got that female doctor is a funny story of its own, but I'll tell that another day. So I got an eye infection. And I tried to treat it with various things, and it just wouldn't go away. Right? I had this big lump, my eyelid had a big lump on it. And I go into the doctor. My wife is like, "Just let me pop it. Just let me." She's like, "I want to pop it." Because my wife's a woman. And I said, "No, it hurts. Like if you touched me here, it hurt. Like my whole face was in agony." I go in to see the doctor. Now, my doctor was a very attractive lady. And I don't know about you, but much like most men, when faced with an attractive situation, you don't want to be a wuss. And I walked in the doctor and I say, "Look, man, I got this thing." She's like, "Ugh. I got to take care of this because I'm in pain." And she's looking at it. And the whole time she's not talking. I'm talking about how it hurt and giving her the history of it. And she's looking at me like this. And she says, "I think I can get it." And I know she's not going to be able to get it. But I'm like, "If that's what you think, doctor, do it." And I sit down in the chair, and I grab the edge, and the doctor comes in, and she went to the gym. She had pipes, like arms like this. And she comes in, rolls up her sleeves, gets right down over my legs, so I'm like this, so she's got to bear down, and she, and with my good eye, I can see her muscles bulging. And I'm just like, and I won't say a word, man. I won't say a word. I'm not even moving. And she's, and then she goes like this, not a word of a lie. She's tired. And I'm just like, oh, thank God it's over. But I don't do that, right? Because I'm a man. Tears are welling up. I'm just like, and she's like, and she gets back in there. Muscles, sweat dripping. And she can't get it. She tried just the 2 times. And she's like, this is probably really hurting you the second time. I'm like, oh, I'm good. She says, well, I don't know what to do with this, man. And she gave me 2 antibiotics. I had to get a cream to rub all over my eye and take a pill. And then it just went away. But that's what it took. I got another story. 7 years ago, I was teaching an ISP. I got a little thing on my neck. Just a little thing. Thought it was a zit. My wife, I'll get that. No, you won't. Leave it alone. All weekend, I don't do anything about it. Sunday, it's a long weekend. Sunday, I'm sitting there, and the whole side of my head is hurting. And I go look in the mirror, and this thing has grown. It's like a volcano. And I'm like, oh my God. It's hurting my head. I'm dizzy. It's a serious infection. So I go to a walk-in clinic. I don't want to be sexist. But who usually greets you at a walk-in clinic? A woman. She looked at my neck and said, oh, well, the doctor's going to want to take care of that. And she goes and she gets a scalpel and alcohol and needles and all this stuff to cut this thing out of my neck. Again, not to be sexist. She puts it down. She's like, the doctor will be with you in a moment. The doctor, again, not to be sexist, but most doctors are men. The doctor walked in. He said, oh, what do we have here? I am not going near that. Here, wrote me 2 prescriptions, cream and pills. I had nothing to do with that, and I left. And my wife's in the waiting room. They take care of it? No, honey. And the receptionist is like, oh. Again, not to be sexist, but in those 2 experiences, and I had a girlfriend in high school that was crazy for it too. It's weird. I don't understand you guys.
Find the crazy chicks.
Maybe I attract crazy women. It could be that. What? Do you count school, or do I have to count summer girlfriends as well?
Oh, summer too.
So, girlfriends from when I entered the 8th grade till grade 12, because in Vancouver in high school started in grade 8. Well, again, how do you define girlfriend? When I was in kindergarten, there was a girl that we held hands and kissed in the reading hut. Does that count? Oh, because it was Shannon. She was gorgeous. I named my dog Shannon because I was so in love with her. I didn't realize that was kind of a put down. I'm going to stop recording now.